Hey physicist, in this problem we're trying to find out really effectively how much our skydiver weighs. We know that we have our parachute falling down at a constant 7 meters per second. So we know that the upward force and the downward force are the same. The downward force is tension force provided by the weight of our skydiver. Our upward force is due to drag from the parachute itself. Hey, let's take a look at what that force of drag is as we drag this thing through the air. Hey, from our previous review, we saw that the force of drag is equal to the density of the fluid that we're moving through times the cross-sectional area that we're trying to drag through there times velocity squared times this funny thing called c, which we kind of defined as our drag coefficient. In this case, we were given a drag coefficient of 1.7. Why is it so high? Hey, almost like a super ball bouncing off of a block. The air has to enter the parachute, stop, turn around to get out of the parachute, and finally make its way around. So it was found that, hey, for many parachutes, that value is about 1.7. Streamlined objects have much lower values of c. And then how do we get here? We know that our impulse is our change of momentum. Dividing each side by time tells us that our change of mass times velocity divided by time is going to be our force. And our mass in this case is the density of our air times the rectangular solid, if you want to think of it that way. The area of the rectangle times its length. How do we get the length? The velocity times the amount of time. Works out nicely that when we divide this by time, our times end up canceling. So we're just left with this value. When we look at v, we're going to end up squaring velocity here. Let's go and put in some numbers. Our density of air, given to us in the problem, I believe, but we can look it up also, 1.23 kilograms per meter cubed. Our area, we can use pi r squared, so pi, our radius 3 meters. Let's go ahead and square that. And our velocity, I believe we're falling at 7 meters per second squared. Sorry, I got a little crowded there. Let's go ahead and punch that into the calculator, see what we get. Anyway, I did my plug and chug. I got a value of 1,704 newtons. What does that work out to be? Let's see, about 5 newtons in a pound. So what does that work over? About a little over 300, about roughly 300 pounds. Hey, there was the additional question. Hey, what if I ended up doubling this force? Let's say I had, the paratrooper with equipment had a weight of 600 pounds. Would our velocity double? And hopefully we can see by this square term, no, it would not, because as our velocity starts to increase, the amount of drag goes up with the square of that. So if we increase the force, or we doubled it, we'd expect the velocity to increase by the square root of 2. So 7 times 1.4, that being the square root of 2. What does that work out to be? 7 times 1.41. I get about, sorry about that, about 9, getting excited there, about 9.8 meters per second. It's just about 10 meters per second. So we certainly see that we didn't end up doubling our velocity. All right, good luck with this one.